Yo, 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 yo. Okay. I'm a bit tired. I feel like a French fry. So I joined Cash App 4 years ago. It's funny because at the time, people on the team were making talks, like testing robots, or like this kind of a pattern and stuff. But so when I joined the team and the code base, I look at the code base, we had views with business logic, all in Rx. In the view, most views didn't have presenters. Like in retrospect, maybe the team was small enough to just move fast and, take risks. So now we have more than 800 modules, 70 Android engineers, and but so interestingly to me, it's the most delightful right now to code on the code base. And so my talk is just to brag about our code base, saying why I think it's the best and why I like it so much. Android provides some APIs, and actually Diane Hagborn in 2016 released a blog on Google Plus, RIP, rest in peace, where she talks about like activities, we have services, providers, like the way to interact with those. But there is a passage in this blog which I think is worth quoting, which is going to start right now. So it is probably better to call the core Android APIs a system framework. For the most part, the platform APIs we provide are there to define how an application interacts with the operating system. Here is the important part. But for anything going on purely within the app, these APIs are often just not relevant. I like this a lot, and this is why I think we found a good ground, because we kind of forget about everything. What is it? The thing we don't like, the fragments. Activities fragments, even like the Jetpack libraries. We took a step back and just what in the ideal world would be an architecture in our case. So we'll see how we make a screen. So until recently, this is how we would do it. We would have a view in Kotlin, not XML anymore. We would inject the presenter or its factory, bound the logic within the view, doing fancy Rx things, and it would actually feel pretty all right. But what's not all right is first, the view knows about the presenter, even though we say it doesn't. If we want to compile the view module, we need to compile all the presenter and the backend, and everything depends upon. So that sucks. We should not do this. This is old school. Okay. Here is a basic idea that we usually take in mind. So we have a presenter which emits UI models. I might call them view model, which means view model, not presenter. And the UI would consume it to render its state. UI model should be sufficient and contain at the same time all necessary information for the view to render itself. So it should not depend, like it should not keep state and remember what was the previous model to render next one. It just like a pure method basically. Whatever the situation for the view, if we pass the same UI model, we should get the same rendered screen. And the UI would emit events, which are basically what the customer or the user would do on the screen, whatever it is. And so the presenter just consumes it, and then it's just a loop. And this being a loop is actually important. The data doesn't go in all ways. It's always only one way, so the famous unidirectional data flow. The presenter, to me, looks like a map. It's basically taking events, emitting models. And so I like this idea, and we'll see how it became used in Rx. But so I don't think the UI can be a map in the other sense, because UI models should not generate events. Never. If you ever do that, you're going to go for trouble, because in between we have our customer. And so If you're familiar with this, it's basically what the MVI architecture was like, or like Cycle.js, these kind of things. The customer is the map, and so we in our UI should not try to bypass it. We have side effects happening. They should stay constrained. The presenter does the business logic. It should never happen in the UI. On the right side, the UI should render on the screen, never reading, so never listening to customers' actions. And on the left side of the UI, we would just listen to tabs, scrolling, whatever it is. So for the examples we will see through the talk, we'll use this screen. So it's basic screen. We have a toolbar, an image, 2 text input fields, and 1 button. So our UI models and UI events are Pojo's businessless, so business, whatever, and like nothing fancy about them, really simple. For UI events, it would be just one. It can be a data class if you have payload to pass along with. So the user could click on the close button or the continue and have fun. So we have a UI concept, which is defined by the UI model it consumes and the UI event it can emit. So we defined event receiver API, which is just a way for the UI to register the callback where it should just kick events. Even though it could be modeled as a stream, we are not using it because we don't feel the need to do so, and so that's a dependency that we can just don't depend on. And then just you have a UI model, render it. That's all we need. That's all we want for our UI. And so Compose UI is the good thing to use, but I'm still in love with Contour and I still use it, so my example will be in Contour for this month. So in Contour we write everything in Kotlin. We don't have XML anymore. We have the 2 methods that the UI interface asks us to implement. And so like in a regular file, you would define all the views you need as members. So we have the palette, which is the way we theme things. You would inline style everything. And the Contour Magic allows you to lay out everything. And so the toolbar would be on the x-axis, you match your parent. On the y, your top is there. Same for the image. I'm sorry. And so all the lambdas in the x and y will be executed on every layout. And so that has been pretty handy to do, I don't know, conditional layout, design, positioning, whatever. So the rest is really simple. Send event receiver, we just bound the click listeners to send the CTA clicked or the close event. And model, in our case, it's just setting the strings. We also have an abstraction to support Compose UI. And so instead of asking views to implement set model and the event receiver, we just pass the content method. So nothing special about this. But so the way we test it, I think, is pretty sweet. Those screenshots are not shots that I took, but something that Paparazzi generated for us, which is the library that we use internally for UI testing. Because we have really simple API with a sentry event receiver and send model, the tests are also really simple. So we set up Paparazzi and we use the test parameter injector to do both light and dark mode. We create our view, we pass the model, and we take a snapshot. Paparazzi also supports XML inflation, so if you have still view in XML, you can do it. With the most recent release, Paparazzi supports Compose UI, so all good as well. And so the test task will run, and so Paparazzi will generate a report for you, which will look something like this. So every time you run the test, it will create a snapshot of your view, and you'll be able to iterate every time on your view, saying what changed, how it looks, I don't know, whatever you need. And so you can see how I iterated over my view until I'm happy with the result. And so we have the same for the light and the dark mode. On CI, the way we would do it, so we write those tests, we would register the snapshots, which is record those, basically generating them. They are going to be created under the snapshots image folder, and those are going to be golden images. So file against which you'll be able to verify that you don't have a regression. So they ought to be checked in, and then you can do it locally or on CI, run the verify task. If you have, if Paparazzi noticed a difference, the test will fail, and so it will say images differ by 7%. You can check the details in something. And so this something is a data image. You have the expected image, which is the one that you've checked in on GitHub or whatever. On the right, the one that's got generated, and in the middle, you can see the delta, which is super helpful to know what's happening. And the most, not the most, but one super cool thing about Paparazzi is that it runs on the JVM. So no need to run emulator, Roboelectric, Espresso, gone. And so there is a great talk you can attend 2 hours ago. You can check the recording later, I guess. So the presenters. Likewise, like the view, 2 arguments, UI model, UI event. We want to tell our presenter when to start working, because it does so much, depends on the presenter obviously, but so much work calling the database, the network, or like whatever. We want it to only start working when we tell it so. And we use a coroutine scope to let it know when to stop. So previously, when you at the view, the slide earlier, inside the view, when we had the presenter injected and subscribed to, the view detaches itself and would dispose the stream. Here, the presenter ought to use the scope to do so. It would be like invoke on completion or cancellation. And this will return a binding saying, so the presenter says to the entity creating the presenter, this is how you are to communicate with me. This is the flow of models I'm going to emit on. And if you want to give me events, use this method. So we actually want to change the models type to a state flow. So to help support on Compose UI, because the view in Compose UI need like a default model. In Rx and Flow, like basically the stream would be created, subscribed to, but would only emit when something is ready. And so I put the to-do to show you that it's still something in progress that we need to improve. Okay, so if you remember, the presenter, I said I thought it was a map. So it's basically just a map doing side effects, which can also trigger other streams or whatever. And so in Rx, this would have been perfect for an observable transformer. We also had a coroutine presenter. This is so this was before Compose happened. We still use both, depending on the feature module we were in. People were kind of free to use whatever technology they wanted to use. I've been using Rx till Compose happened. Some other use coroutine presenter. it doesn't really matter, and we'll see why we were able to use both. But so in observable transformer, this is how it would look like. We would inject everything. Here we hook up the events. So we filter, if we have a CTA clicked, we start a flow. If we get a close, we go back. Nothing fancy. And then we have the models. We listen to the database, get the text value that we want, start with the default one, and emit something. So this example is pretty simple. But we can see already that Rx and will have the same thing with flow. We add a lot of operators, which makes the code hard to read, hard to code sometimes. But it wasn't actually hard to test because of the interface, which is, again, only one entry point, events, only one output. So the first test, we just assert that a view model has been emitted, all good. The second one, we pass an event, we confirm that the side effect happened. That's it. And it's been actually pretty easy to write, easy to review, easy to understand. So Molecule is my kind of the favorite library that we made recently, even though it's kind of simple. So there was another talk about this, obviously. Compose UI, so you have a composable method, this time returns unit, where you can create views and everything. But so, it was the same with Rx, the same with Flow, and the same with composable. It's just something reactive, which emits on different ways, but it's just the same, something reactive that emits. And so, what if we could do something like this? We have the presenter, takes two flows, return the model. And so we listen to the flows, get the state flow out of it, and then we can just write imperative code, like the simplest you can get. There are no nesting, not really any confusion around what should go first or these kind of things. And because it's composable, you can still reuse all the tools that we have to manage state in between composition. But so once we have this, we need to make it, like we need to consume it somewhere. And so that's what Molecule brings. It basically takes a composable and makes a flow out of it. And so we have two recomposition clock. One is basically taking the Android one, so the one that choreographer drives, which is, let's say every frame, when the state is dirty, we're going to emit a new composition. And the immediate is anytime the state is dirty, we emit. There is another method that Molecule exposes, which is launch Molecule. And so in that case, it's bound to a coroutine scope. And instead of returning a flow, return a state flow. So you would use this if you want like a state right away. Instead of waiting on a flow to emit, you would get like a state immediately. And so for instance, Molecule flow would be used in tests, or maybe something that I've done as well. So let's say I have an old Rx-based presenter, which want to use a composable presenter or like whatever tool that we have somewhere else. I can use Molecule to, from this composable, make a flow, and then I can use the regular as observable helper, and then I can use it in my observable transformer. Molecule flow is good for this. Launch Molecule would be more if you want to directly bind the model emitted by this presenter to the view. So anyway, up to you. So we had those two types to define presenters within the app. But so big thanks to Molecule, we have now another one, which is the one I use everywhere, which is great. So again, we pass flows of event. It emits UI model. Even if the signature doesn't make it seem like it's like a streaming flow, because it's composable, it will just emit every time there is something to emit, but compose, abstract away all this reactiveness. So the presenter we saw earlier in observable transformer, now in molecule presenter that would be something like this. We again inject what we need to inject. We hook up the events. So it's now a basic when statement on the type of the event. If it's clicked on the CTA, we start a flow, otherwise we can navigate. We remember to start a flow on the database, and we obviously don't want to create a new flow for every composition. We collect a state with a default value, and a simple return statement at the end. So there are no before-after with the observable transformer, but this is really simple to write, even simpler, more simple to understand. This is just top-notch. I really like it. And test as well. So because molecule takes a composable and make it a flow, for testing you can use turbine, whatever, because that's the library you want to use for testing. This is great because it also makes sure that you don't forget to consume events, or that error not happening or whatever. And again, as you can see, the tests are pretty simple to understand, easy to review, easy to write, which is always helpful. Every time you have a small friction in testing or whatever process of programming, this will add up in time and it's going to fire back, or like people would stop writing tests or these kind of things. So it's really important to have simple tests. And I've used molecule as well for something else. Something below the presenter, say I have like a backend manager somewhere which emits from the database or maybe the network or gathering data. I like now to make those composable, and molecule is the tool that I use to make the bridge between, say, a composable and some RX presenter, flow presenter, it doesn't matter. We can reuse the same API we have to store state between composition. The code is just simple as you can get. I don't really know how I would write it in RX right now, but like if like we didn't read from the database yet, just return loading, otherwise we have a content. Every time the database is updated, we'll have a new content. Like the simplicity is just its strength, I think. So there are two talks about molecule. One tomorrow afternoon, and the other one was this morning. So if you didn't make it this morning, you can check it tomorrow. So navigation. So now we know how to make a screen. We have the UI, the presenter. We bind them together, we have a screen. So how do we go from one screen to another one? So first, to define let's say a location in the app, we use this type of screen, which extends possible because we want to be able to store, save the location where we are at and restore this. And as an example, a screen would be something like this. The stock details, which would take the customer to the stock details view with some payload that the container would be able to pass either to the UI or to the presenter. The navigator is just this. We have a screen, take me to it. So really simple interface, nothing fancy about this. We usually inject it to our presenter right now. And so say earlier the customer click on a button, we need to go somewhere. We inject the navigator to the presenter, and so in the test we just, okay, did the navigator went to a screen? So the tests are easy to write as well. And so this is why I wanted to talk about Broadway. Broadway is the name of the not open source library that we have internally that we are trying to kind of create. It's still pretty, what's the word? It still have a lot of implementation details related to Cash App. So it's not open source yet, but it's something we've been working on. It's actually pretty simple. It contains mostly all the interfaces that I shared, and then some glue to make the bridge between molecule to flow to Rx and these kind of things. But there is something else that we want. Like when I said that the view should not know about the presenter, and vice versa. We also don't want modules to be exposing their views or presenter details. And so for that, we created factories. Say in Cash App we have the investing presenter module, the investing view modules. Each of them will only be exposing the view factory that they have. And so the view factory would be basically a when statement on the screen. If it's this screen, like the stock details, okay, then inflate this view. If it's an XML, we can inflate it on the spot. If it's not, we can just instantiate it. If it's composed the same, we return it. If it's a presenter, same when statement on the screen. If it's this, then take me this presenter. And so you remember that we have 3 kinds of presenter. And that we have those bridge method again, which would take an observable transformer and make a presenter out of it. There is nothing really difficult about this. It's just making sure that past events are going to go through the stream of the observable transformer. Models are going to emitting back. And the scope will be used to let the observable transformer when to dispose itself. We will have the same with the coroutine presenter. And lastly, we have the same for molecule presenter. So we have 3 methods that will let anybody in any module write the presenter that they like the most. We can come up with a new type, it doesn't matter. We just need the bridge method. This also allowed us to slowly migrate code to new technology. So we still have Rx code, we still have flow code, and like molecule is taking over. So feature module should be exposing the view factory, the presenter factory, and everything else inside this module should basically be internal. And I think that's great. So now the glue. This is actually the tricky part. So the way we do it, we have, so each module would be using a Dagger module, exposing its view factory or its presenter factory into the DI graph. We provide Broadway with all those factories. And then so we have the container at the root of the app. It's like one big frame layout, which takes Broadway. And every time so this is a navigator. And every time there is a navigation to happen, it's like, OK, Broadway, I have this screen, give me the view. Hey, Broadway, I have this screen, give me the presenter. And then the magic happens. We bind them together. We attach the view, do some swapping and things. So if you want to try it at home, you take Broadway, you hook up your view factories, presenter factories, and then you just draw the rest of the owl. So what is the rest? First, there is the view swapping. So we don't, at Cash App anyway, we don't use any of the libraries, any of the public libraries. Everything is in-house. So we need to take the current view, to remove it, to put the new view. When we remove the old view, we need to kill its presenter, its view, these kind of things. We also have animation. When we do this, kind of related to the view and presenter factory, we have animation factory that every feature would be able to expose. Broadway would be, OK, I have this screen. I'm going to this screen. Is anybody interested in giving me an animation? If we have one, we use it. Otherwise, we have a default animation. Same with overlay. So we have the view, but we want to show, let's say, a dialog or a bottom sheet, or anything that doesn't take over. We need to keep the current view, add something on top. If the customer press back, we need to be able to remove this overview without killing the active view. Sorry. And so the backstack as well. This is just difficult. We have one big kind of a code view, which like the old backstack saying, when we go to this screen, maybe we want to pop up some things, maybe we want to modify some things, maybe we want to check the payload or whatever. It's actually been like a mess. We are still looking at the kind of API we could come up with, but it's still something we think a lot about. Config changes, so we kind of cheat on this because we don't support it, like we stay on a portrait all the time. But this isn't something that Broadway should think about. Whatever the container was, using Broadway to get a view and a presenter, this one should take care of those, ideally. And then I'm sure there are many things that I didn't think of. And so that's it. I have a few references for all the libraries that I talked about and that we still use. Broadway isn't in existence yet in the wild. It might be someday, it might not. We are not sure, but this is the idea we are iterating over on our work. Thank you.